Hi everyone and welcome to today's video. My name is Emmanuel Olega and I'm a math teacher and a software engineer. The purpose of today's video is to help a student in Senior 5 or Senior 6 preparing for their UNEB and who wants to get better in their knowledge of applied mathematics, or what they call Math Paper 2. So today I'm going to be introducing the topic of vector mechanics. And this is going to be a very key and essential part of applied mathematics. Without wasting time, let's learn something about vector mechanics. Alright, so today we begin with vector mechanics. So what is a vector? A vector is a quantity which has both magnitude and direction. So examples of vectors or vector quantities can include force, displacement, velocity, acceleration, momentum, etc. etc. So there is more, and now the opposite of a vector quantity is actually a scalar quantity. So scalar quantities are those that actually have magnitude but they don't have direction, and one of the examples of that is time, for example, and many others. But today we are focused on vectors or vector quantities. So how do we represent a vector? So we're going to look at the representation of a vector. So a vector is represented by a line with an arrow indicating the direction of the vector. So remember that a vector is both magnitude and direction. So this is an example. So here we have an arrow. We have a straight line and there is an arrow pointing in a certain direction. So the line said from point O and it's pointing towards point A. So the direction is from point O to point A. So where the order of the letters shows the direction. So we shall consider vectors in 1, 2, or 3 dimensions. So that's what we're going to be doing in this category. So in 2 dimensions, a vector can be represented by OA. Of course, OA represents us moving from point 0 to point A, and we can represent that as small a. Or we can have A, small a, being equal to XY. So that's more of the column form of that vector. Or thirdly, we can also represent that same column as A being equal to XI plus YI. So actually you should not all these three represent the same thing, and then we shall actually be using them interchangeably during this course. Alright, so here is an example of how we can actually represent a 2-column individual vector. So this is what we have. So we have the vector, we're moving from point O to point A, and we're representing that vector with small a. So as you can see, we can actually represent it this way. So these are the X and Y coordinates of the direction, but this is how we represent the 2-dimensional vector. Alright, so in 3 dimensions, a vector R can be represented by R is equal to X, Y, Z. So that's how we represent it in column form. Or we can represent it as R being equal to Xi plus Yj plus Z. Okay, so we can use these two interchangeably. So this is how we can represent it. So this is it in 3 dimensions. Alright, so let's look at some elementary options on vectors. So a vector is represented by a line with an arrow indicating the direction of the vector. So let's look at vector addition. So in adding vectors, we add components of vectors in the same direction. So for example, given the vectors A is equal to A1i plus A2j plus A3k and B is equal to B1i plus B2j plus B3k, when we are told to add vectors A plus B, we can have it this way. So as you can already see, we're adding the components that are in the same direction. So where there is I, we add where there is I, we add that to where there is I. Where there is J, we add that to where there is J. And where there is K, we add that to where there is K. So in the end, we'll have A1 plus B1 bracket I plus A2 plus B2 bracket J and plus A3 plus B3 bracket K. So that's how we do addition. How about vector subtraction? So in subtracting vectors, we subtract components of vectors in the same direction. So for example, given these same vectors right there, A minus B is, so we'll have this A1 minus B1 I plus A2 minus B2 J plus A3 minus B3 K. So that's how we do the vector subtraction. So let's look at some examples to understand this further. So given vectors a is equal to 2i minus j plus 3k and b is equal to 4i plus 2j minus 2k, we're being told to find the vector c is equal to a plus b. So now c shall actually be equal to a plus b, the sum of those vectors. So when you add, we'll have c being equal to, so if we're adding, we'll have 2i plus, 2 plus 4i, and then we have, now this will be a negative 1 because the coefficient here is negative 1. So we have negative 1 plus 2j, and then we'll have 3. Now it would have been plus negative 2, but because the minus affects the plus, we'll have it as 3 minus 2 bracket k. So therefore we'll have c being equal to 6i plus j plus k. So in question 2, we're being given the vector p is equal to 3i plus 2j minus k and q is equal to I minus 3j plus 4k. And we're being told to find the vector r, which is p minus q. So as you can see, r shall actually be equal to this. So we'll have 3 minus I, because 3 minus 1 because the coefficient here is 1, and then 2 minus, now because this is already a negative, the coefficient here, so to become a plus, so we'll have 2 plus 3j, and then we'll have negative 1 because the coefficient here is negative 1, negative 1 minus 4 bracket k. So r shall be equal to 2i plus 5j minus 5k. So that's how we do vector addition and vector subtraction. So next we look at scalar multiplication. So when multiplying a vector by a scalar, all components of the vector are multiplied by the scalar. So for example, given the vectors a, so now in this case we're representing them in vector form. So remember that this is the same as when we could express them in the form of ai, a to j and all that. So this is just another way of representing them. So it's basically the same thing. So given the vectors a is equal to that and b is equal to that, and the scalars lambda and beta, then 1. If we have lambda, if we're being told to multiply lambda to vector a, it's the same as lambda times this column vector, of which our answer shall be, so as we've said, we'll multiply the scalar on all components of the vector. So we'll have it as lambda a1, lambda a2, and lambda a3. So next, if we have lambda a plus beta b, as you can see right there, and we're being told to multiply, to add these two, we'll have this as lambda a1 plus beta b1, lambda a2 plus beta b2, and lambda a3 plus beta b3. So this is another way we can actually represent this and add the two. So let's look at an example. So given a is equal to negative I plus 2j plus 3k, and b is equal to 4i minus 5j plus k, determine the values of 4a plus 3b and bracket negative 3a minus 2b. So let's look at that. So now we're looking at the first case where we have 4a plus 3b. So right here we can actually say that the 4 and the 3 are actually acting as the scalars in this case. So as you can see, this will become, so we'll have this 4 times this negative 1 shall give me negative 4 plus the value that you get from 3 times 4, which is 12. So I have negative 4 plus 12. And then next I have 4 times 2, which is 8. And then plus, but we have 3 minus 5, 3 times 5, which is negative 15. So I'll have 3 minus 15 because this negative plus sign will be affected by the negative. So next I have 4 times 3, which is 12, plus 3 times 6, which is equal to 18. And therefore, I'll have 4a plus 3b being equal to the column 8, negative 7, 30, which is the same as 8i minus 7j plus 30k. So as you can note, this is just another of representing them, and this is also okay. So you can leave everything in vector, in column form, and that will be fine. Alright, so next we're being told to solve this where we have negative 3a minus 2b. So it's the same as having the scalars multiplied into them this way. So as you can see, I have it as negative 3a minus 2b being equal to, so I have 3 times negative 3 times negative 1 shall give me positive 3 minus 2 times 4, which is 8. So that's why we have it that way. Then we have negative 6. Now remember that we have a negative sign here. So negative 6. Then we have negative 2 times negative 5, which is will give me a positive 10. So I will have a negative 6 plus positive 10. And then next I have negative 3 times 3 is negative 9. Then I have it as minus negative 2 times 6, which is negative 12. So I have my answer as negative 5 for negative 21, which can also be expressed as negative 5i plus 4j minus 21k. Alright, so next I look at modulus or magnitude of a vector. So a modulus or magnitude is the length of a vector. So for example, given a vector a is equal to a1i plus a2j plus a3k, the modulus of the vector a is denoted by these bars and given by modulus of a is equal to the square root of a1 squared plus a2 squared plus a3 squared. So that's how we find the magnitude. So that is the formula. So let's look at the next one. How about unit vectors? A unit vector is a vector of magnitude of 1 unit. If A is a vector, the unit vector in the direction of vector A is denoted by, now you can see that sign, we represent it as, so as you can see this A has a heart on it, which can also be represented as a caret or circumflex accent. So that's another way of referring to that heart that you see right there. So the unit vector of A is actually equal to A itself divided by the magnitude of the vector A. So that's how we get the unit vector. So unit vectors are mainly applied when expressing quantities into vector form. So this will become useful in some moment as we solve some numbers. So we're going to be expressing some quantities into vector form. So take note of that. So how about parallel vectors? So two vectors A and B are said to be parallel if they are in the same direction. So whenever two vectors are parallel, one vector can be obtained by multiplying the other by a scalar. So take note of that. So therefore we can have B being equal to HA, where H is a scalar. So if a vector of magnitude R, so this is another example. Now this is a continuation of where I said we can actually use unit vector to express magnitudes into vector form. So if a vector of magnitude R moves in direction a1i plus a2j plus a3k, then R shall actually be equal to the magnitude of R times the unit vector of the direction. So as you can see, this is the unit vector of the direction. So we have the magnitude of the component here, and then we have the unit vector of the direction component right here, as you can see, and that will give us R. So let's look at some examples. We're being told to find the magnitude of B is equal to 3i plus 2j minus 6k. So as you remembered, we know that the formula finding magnitude shall actually be equal to square root of this individual. So we have 3 squared plus 2 squared, and this is a negative 6, so we'll have negative 6 squared, of which we will have it as square root of 9 plus 4 plus 36, which is root of 49, of which the answer shall be 7 units. So that is the magnitude of the vector B. In question 2, we're being told to find the unit vector of A, which is equal to 6i minus 2j plus 3k. So remember the formula for unit vector is given this way. So the A with the heart is going to be equal to A over the magnitude of A. So we'll have it this way. So it's going to be 6i minus 2j plus 3k over square root of 6 squared plus, into bracket we'll have negative 2 squared plus 3 squared, of which we shall have it as 6i minus 2j plus 3k over root 49, which is 7. So I have 6i minus 2j plus 3k over 7. So lastly, I can actually extract out the 1 over 7, and I have it as, I have the unit vector of A being 1 over 7 times, into bracket 6i minus 2j plus 3k. Alright, so let's continue. So moving on to question 3, we're being told to find the magnitude of the vector 3, 4, 6. So now the vector has been given in column form, and hence write down a unit vector in the direction of 3, 4, 6. So how do we do this? So we're going to let that vector be M, and therefore the magnitude of M shall actually be equal to the square root of 3 squared plus 4 squared plus 6 squared, which is going to be equal to root of 61. 1, and therefore the unit vector in that direction shall actually be 3i plus 4j plus 6k over root of 61, because we've been given the direction as 3, 4, 6. So that's why we have it that way. And then I can extract out the 1 over root of 61 times the column vector 3, 4, 6, and that shall be the final answer. So next we're being told to determine if the vectors, so these are two different columns, 1, negative 2, 3, and negative 4, 8, negative 12 are parallel or not. So how do we do this? So these are the two vectors that we actually have. So when I actually look at the column vector on the right hand side, I can actually see that I can actually factorize out a negative 4. So when I do that, this is what I'll have. I can see that I'll be left with 1, negative 2, 3. So I can already see that the two vectors are parallel because one vector can be obtained by multiplying the other by a scalar, of which this is in the negative 4. So since this and this are similar and we have this being multiplied by this scalar, it means that the two vectors are parallel. So in question 5, we're being told to find the vector which has a magnitude of 15 units and is parallel to 16i plus 12j. So in this case, we've been given a magnitude component and then we've been given a direction. Now when we say a vector is parallel to something, it means that they actually share the same direction. So how are we going to find the vector for this? So we're going to be using the method r is equal to magnitude of r times that. So now in this case, this is the magnitude component already given, so this is what we're going to have right here, and then the r is going to be the vector that we're actually looking for, times, now we're going to be needing the unit vector direction component. So this is the unit vector of the direction component which we've been given right there. So we're going to have it as r being equal to 15, which is the magnitude, times, now we have this direction component because they are now parallel, so this is what we're going to be using as direction component, 16i plus 12j over root of 16 squared plus 12 squared. So we shall have 15 times that, and then we can actually say this will become root of 400, which is 20. So now we have r being equal to 15 times 16i plus 12j over 20. So we can, when we extract out 1 over 20, this is what we end up having. Now this and this can reduce and I'll be left with 3/4 times that. And then if I multiply 3/4 within, I'll have r as 12i plus 9j, and that shall be the vector which has the magnitude of 15 units and is parallel to 16i plus 12j. Alright, in question number 6, we're being told that a body of velocity v and of magnitude 20 meters per second moves in the direction 6i plus 8j. So being told to find v, so we need to find that vector v. So v shall actually be equal to the magnitude of v, which is already given right here, times the direction, the unit vector of the direction, which shall actually be that. So have v being equal to 20 times into bracket 6i plus 8j over root of 6 squared plus 8 squared. So I'll have it this way. So we shall have v being equal to 20 times 6i plus 8j over root of 100, which shall actually be equal to 10. So I can extract out the 10 and I'll have 20 over 10, which shall actually give me a 2. Then if I multiply 2 inside, I'll have v being equal to 12i plus 16j, and that shall be the value of v. So that shall be the vector v. In question 7, we were being told that a force of magnitude 12 newtons acts on a body in the direction 2i plus j plus 2k. Find vector form of the force. So this is actually similar to those that we've just been doing in prior. So we'll have the force being equal to the magnitude of the force times the unit vector of the direction. So we're going to have F being equal to 12 times 2i plus j plus 2k over root of 2 squared plus 1 squared plus 2 squared, which I'll have it this way. So inside there I'll be left with the root of 9. Now root of 9 is 3, so I can extract out the 3, and 12 divided by 3 is going to be equal to 4. So multiply that 4 inside and I'll have the vector form of the force being equal to 8i plus 4j plus 8k, and that is the answer that they wanted. Alright, so moving on, let's look at scalar product or dot product. So the scalar or dot product of vectors A and B is A dot B being equal to the magnitude of A times the magnitude of B cos theta. So in this case, theta is the angle between the vectors A and B. So that's important for you to note. So if A and B are parallel, now remember something parallel, it means that the angle between them shall actually be 0 degrees. So if the A and B are parallel, that is theta shall actually be equal to 0 degrees, because therefore the angle between them is 0. So we'll have A dot B being equal to the magnitude of A times the magnitude of B cos 0. And that cos of 0 is 1. So we'll be left with A dot B being equal to magnitude of A times magnitude of B. So this is true in the case where the two vectors are parallel. Now if the two vectors A and B are perpendicular, that is when theta is 90, we'll have A dot B being equal to magnitude of A times magnitude of B cos 90. But cos of 90 is 0. So that means A dot B shall actually give me 0, because 0 times anything is 0. So the dot product is very useful when finding the angle between two vectors, and then when finding the component of a vector in a given direction. So this is when we're going to be making use of the scalar product. Alright, so let's look at an example. So being told that two particles P and Q are moving with constant velocities 8i plus j minus 4k and 4i minus 2j minus 4k respectively. Find the angle between the parts of the particles. So now, as we've said, when we're dealing with finding the angle between two different vectors, we actually use dot product. So we can say that P dot Q shall actually be equal to the magnitude of P times the magnitude of Q cos theta. Now in this case, we can let's express this in column form. So we'll have it as 8, 1, negative 4 times 4, negative 2, negative 4 being equal to, now the magnitude of P shall actually be equal to root of 8 squared plus 1 squared plus negative 4 squared. Then times root of, where there is Q, I'll have it as 4 squared plus negative 2 squared plus negative 4 squared. So I have on this side, when I multiply two different vectors, I'll have it this way. So I'll have 8 times 4 plus 1 times negative 2, which actually give me a negative 2. So that plus will be affected and I have it as a negative 2. And then plus negative 4 times negative 4, which is 16. So that's why I have it that way. Being equal to, so this will give me root of 81 and this will give me root of 36 cos theta. So this will give me 46 being equal to, this will be 9 times 6 cos theta, which I have 46 being equal to 54 cos theta. So making cos theta the subject, I have it as 46 over 54. So theta shall be cos inverse of what you get from 46 divided by 54. Of course, from here I get 0.852. Now cos inverse of that shall be equal to 31.6 degrees. And therefore, that shall be the angle between the parts of the particles. So the next question, we're being told that if the angle between two vectors, A being equal to xi plus 2j and B is equal to 3i plus j is 45 degrees, find the two possible values of the constant x. So in this example, we've been given the angle and we want to find the values of x. So how do we do it? So again, going to use dot product. So we have A dot B shall actually be equal to magnitude of A times magnitude of B cos theta. So let's put everything in. So here we'll have x2 times 3, 1 being equal to the magnitude of this, which should be x squared plus 2 squared times 3 squared plus 1 squared, which times cos 45, which because the angle between them is known. Now here x times 3 is 3x plus 2 times 1, which is 2, being equal to that. Now here, this will give me 3 squared plus 1 squared is 10. So I have root of 10 times. Now, cos 45, if put in fraction form, is the same as 1 over root of 2. So as I can see, I can actually combine these two and I'll have root of 10 over 2, which is root of 5. Now I can clearly multiply these two together with the knowledge of sides and I'll have 5x squared plus 20 inside a root. So squaring both sides to eliminate that root, I'll have 3x plus 2 bracket squared being equal to 5x squared plus 20. Now square these and actually expand. I'll have 9x squared plus 12x plus 4 being equal to 5x squared plus 20. So when I collect like terms, I'll have 4x squared plus 12x minus 16 being equal to 0. Now this is a quadratic equation. So I can say I can divide all by 4, both sides by 4, and I'll have x squared plus 3x minus 4 being equal to 0. So now with the knowledge of quadratic equations, when I choose to plug into my calculator, I'll have x being equal to 1 or x being equal to negative 4. And these shall be the two possible values of the constant x. Alright, so next question, we're being told to find the value of a for which the vectors ai minus 2j plus k and 2ai plus aj minus 4k are perpendicular. Now remember something, we've said it before, that when two vectors are perpendicular, it means that the angle between them is equal to 90 degrees. So that means that we have cos of 90 somewhere, but remember that cos of 90 is 0. So that means that a dot b shall actually be equal to a, I mean the magnitude of a times magnitude of b cos 90, but you know that cos of 90 is 0. So that means that a dot b shall actually be equal to 0. So now let's put the two columns there. So we'll have it this way. So now multiply all and we'll have a times 2a, which is 2a squared, plus negative 2 times a, which will be a negative 2a. It will affect the plus sign and we'll have a minus 2a, plus now 1 times negative 4 is also a negative 4. It will also affect the plus and we'll have minus 4 being equal to 0. So we're going to solve this using the knowledge of quadratic equations. But I can say I can divide all sides by 2 and I'll have a squared minus a minus 2 being equal to 0. So I'm going to use my calculator and I'll get a being equal to 2 or a being equal to negative 1. So these are the two values of a when the two vectors are perpendicular. Alright, so next let's look at vector product or cross product. So given the vectors a is equal to a1i plus a2j plus a3k and b is equal to b1i plus b2j plus b3k, the cross product of vectors a and b is given by a times, a cross b being equal to, so we'll have these inside bars like this. So we'll have the column where there is I values, so we have I values in a column. There we have a column for j values, which are a2 and b2, and then we have a column for k values, a3 and b3. So this is how we deal with cross product. So when we actually want to find the cross product, we'll actually have it this way. So this is how we solve it. So in this case, where we're looking for the part where we have I, as you can see right here, we'll actually have it this way. So we'll have a2. So when you're dealing with I, you're going to ignore this side where there is I and you're going to focus on this. So then we're going to cross. So remember the meaning of crossing. So we'll have a2b3 minus a3b2. So that is for the I group. So when you go minus, so I have a minus sign right here at the beginning. So when you go to the J group, we're going to ignore this right here. So we're going to be focused on this column and this column. So let's cross them. So we'll have a1 b3, cross it that way, minus a3 b1j. And then the next part is we shall now have a plus. So remember that at the beginning here we have a minus, then next we shall now have a plus. So the next one is now we're looking for a group where there is k. So at the k side, we're going to ignore this column here and we're going to cross the I and j column. So we have a1 b2 minus a2 b1 with k outside. So that's how we solve the cross product. So the cross product is useful when we want to show that two vectors are perpendicular to each other, and when we want to find a vector perpendicular to any given two vectors. And it's also very useful when finding the equation of a plane. So that's why it's useful. So look at this question. We're being told to find a vector perpendicular to both a is equal to I plus 2j plus 3k and b is equal to 2i plus j plus 2k. So this is what we're going to do. So we're going to actually cross them. So this is what we have right now. So for the I values we have 1 and 2. For the j values we have 2 and 1. And then for the k values we have 3 and 2. So when we cross them, we'll have 2 times 2 minus 3 times 1i minus 1 times 2 minus 3 times 2j plus 1 times 1 minus 2 times 2k. So when you multiply those, we'll have 4 minus 3i minus bracket 2 minus 6j plus bracket 1 minus 4k. So I have I minus into bracket negative 4j plus bracket negative 3k. So open those up and I'll have I plus 4j minus 3k. So this is the vector perpendicular to A and B. So the value you get from the cross product is actually that vector that is perpendicular to A and B. Alright, so question 2, we're being told to show that A is equal to 3i plus 5j minus 2k and B is equal to 3i minus 3j minus 3k are perpendicular to each other. So how do we do this? So we're going to cross both of them. And then when we cross them, we'll have 5 times negative 3 minus bracket negative 2 times negative 3i minus into bracket 3 times negative 3 minus bracket negative 2 times 3j plus into bracket 3 times negative 3 minus 5 times 3k. So solve those and we'll have negative 15 minus 6i minus bracket negative 9 plus 6j plus bracket negative 9 minus 15k. So we'll have negative 21i plus 3j minus 24k. So now we have the vector that is perpendicular to both of them. Alright, so next I'm going to find the modulus of all the different vectors. So first of all, we're going to find the modulus of the cross product or the vectors is perpendicular to both of them that we've actually found right now. So let's first find its modulus. So it shall be root of negative 21 squared plus 3 squared plus negative 24 squared, which shall give me root of 1026. So next we're going to find the modulus of A, which shall actually be equal to root of 3 squared plus 5 squared plus bracket negative 2 squared, which shall be root of 37. And then the modulus of B, which is root 3 squared plus bracket negative 3 squared plus bracket negative 3 squared, which shall give me root of 27. Alright, so to show that the two vectors are perpendicular to each other, we're going to get that magnitude of the cross product that we had found, and we're going to use it to subtract the product of this and this, the product of the modulus of A and modulus of B. And if the answer is 0, then they are perpendicular. So now we have the modulus of the cross product minus modulus of A times modulus of B. So now we shall have root 1026 minus that of root 37 times root 27. So what shall we have? We'll have it this way, and then the answer shall be equal to 0. So since the modulus of the cross product is equal to the product of modulus of A and modulus of B, then A is perpendicular to B. And that is the answer they wanted. And lastly, I have an exercise for you. These are numbers that you can try out to see how good you are at vector mechanics. So try to do these and actually try to get your answers and compare with what you actually have right here. So before I even allow you to do the exercise, I want to just give you a reminder of something. So look at this situation here where we actually don't have the I value in this vector. So what that simply means is the coefficient of I was actually 0. So you may have cases where you only have a j, where you only have a k. What that simply means is that the coefficients of those other parts of the vector where there is I, j, o, all that, it means that the coefficient is 0. So that is actually just the meaning of that. So just try this out and get better, compare your answers to what is given, and I believe that after this you'll actually be good at the vector mechanics. Thank you so much for watching. Thank you so much for watching this video. I hope the video really helped you. I hope the numbers were sufficient for you. If this video was of help to you, feel free to give the video a like, a thumbs up, and then feel free to share the video with all those that you can and help them out if the video really helped you. And then you can leave a comment down in the comment section for me and I'll get time to reply to you. Thank you so much for watching. I'll see you in the next video.